Learn to troubleshoot, how to fix algorithm performance. Imagine your program is running slow or giving wrong results. It can be frustrating, but the good news is you can fix it. Today, we will look at how to troubleshoot and improve your algorithm's performance. First, start by pinpointing where the problem is. Use profiling tools to see which parts of your code take the most time or use the most memory. These tools can show you hotspots, sections that slow everything down. Once you find these, you can focus on fixing the real issues instead of guessing. Next, analyze your algorithm's complexity. Think of complexity as how the running time or memory grows as your input size increases. For example, an algorithm with quadratic complexity, which is written as O of the square of the input size, will slow down a lot with bigger data. On the other hand, an algorithm with logarithmic complexity, written as O of the log of the input size, scales much better. Knowing this helps you decide if you need a more efficient method or data structure. Now, review your implementation carefully. Logical errors can cause your algorithm to do extra work or behave incorrectly. For example, redundant calculations or unnecessary loops can slow things down. Check your conditions and loops to make sure they only run when needed. Sometimes, a small mistake like an incorrect condition can cause the algorithm to repeat tasks or process data unnecessarily. Optimizing data structures is also key. Using the right data structures can make your code run faster. For example, replacing a list with a hash map for lookups can save a lot of time. Also, refactor your code to remove redundant steps and make it clearer. Clearer code often runs better because it is easier to spot inefficiencies. Testing with real-world data is important too. Use diverse data sets that mimic actual usage. If you only test with small or simple data, you might miss performance issues that appear with larger or more complex inputs. Running tests with different data helps you see how your algorithm performs under various conditions. After making changes, measure your performance again. Reprofile and benchmark your code to see if your fixes worked. This step confirms that your adjustments actually improve speed or reduce memory use. If not, revisit your assumptions and try different approaches. For very large data or complex tasks, consider parallel processing or asynchronous execution. These techniques allow your program to run multiple tasks at once, speeding up overall performance. But be sure to understand the trade-offs and implementation details before applying them. Finally, document your process. Keep track of what you changed and why. Peer reviews can catch mistakes you might overlook. Sharing your troubleshooting steps helps you learn and improves your skills over time. Remember, fixing algorithm performance is a mix of correcting logical errors and making your code more efficient. Profiling and testing are your best friends here. Always understand what your algorithm is supposed to do before making big changes. This way, you can target the real issues and avoid unnecessary work. With patience and systematic troubleshooting, you'll be able to boost your algorithm's speed and accuracy effectively.